Hey everyone, welcome back to the Broke Coder. Now, continuing where we left off in the last video, what we have done so far is we created a class called Earth, and in this class we have a show status method and an init method, and then we gave it a parent class with the name, planet, and that class is defined over here. It has an init method as well, and it has a show star method as well. So before we move on to other topics, there's just one more thing that we need to discuss about inheritance. So unlike other classes such as Java, which do not allow multiple inheritance, which means that a child class should not have two parent classes, in Python, child classes can have more than one parent class. Let's just go ahead and create another parent class. Let's call this class as class solar system, and let's give it an init method. How about this? And we'll have it print saying this object is inside the solar system. How about that? Now we have another class and we'd like the Earth class to inherit from it. So what we can do is just add a comma and add the name. Like you could add as many classes as you want, saying class 3, class 4, and so on and so forth. Doesn't really matter. No, it depends on the number of classes that you have and how many you want. So when you wanted to call any other the init method from Earth class, what we used super. We used super here to call the init method of planet. So how do we call the init method of solar system? For that, what we need to do is we need to say we need to say the name of the class that we want. So here in that case, it would be solar system dot double underscore init. And we need to pass self again here. Now, keep in mind that when we called it the previous time, we did not need self keyword, as in over here. We did not have to specify self before this variable of ours or anywhere else, but when you are calling especially the init method from a multiple inheritance point of view, you need to mention self keyword. Just keep that in mind. So with that, if we now run this program, we get in planet class, and we also get that this object is indeed inside the solar system. That means we are able to bring data from the other parent class as well. So let's get rid of that because we don't have any other use for it right now. And we also need to get rid of this and that. Okay, so now what we can go ahead with is encapsulation. Now, if you remember from the last time we discussed encapsulation back in the first video, you can think of encapsulation as kind of like security, not exactly like security. It is the access you give. Not everyone should be able to just come in here and change your own data, change your own values. You don't want anyone to be able to reassign values inside your class. So for that, you use encapsulation. You wrap around the data. That is the technical term, wrapping of data. You make sure that the data stays in one place and it's not just widely accessible to anyone and everyone. So let's create a variable here. This will be a class variable. And let's give it a name, say life form, signifying what type of living beings are on Earth, and we'll give it a value of carbon because we all are made of carbon. Yay. So let's get rid of this show status. Otherwise just let the show status be here. I'll add a print method inside here. Inside show status, I'll say print the living beings are made of hold on, and I'll say self dot life form. So if I print this now, what I should be getting is, yeah, in planet class, the population 20,000, the duration of the 100 days, and the living beings are made of carbon. Now, imagine that someone decides to try to change this value. Now, is it possible? That's the first question. Can I change the value of a variable that's defined inside class? It depends. This variable here is not a proper, how do you put it, data encapsulated variable. So what you can do is you can access that variable here saying planet Earth. That's the object's name here, the object for the Earth class. And you can say life form. And let's just give it a fun value of nitrogen. Because if that were to happen, all of us would die immediately. Let's start killing the world. Okay. So you have nitrogen here. And let's see if in our print statement, instead of saying living beings are made of carbon, we get living beings are made of nitrogen. And indeed we do. That means we were able to change the value of this from carbon to nitrogen. Now what do you do? Like, you don't want anyone messing around with your data, right? So for that, what you need to do is whatever data you add here, you can just add a double underscore in front of it. And what that does is it essentially makes your data not accessible outside of your class. And it certainly can't be changed outside your class. So I've changed it over here as well. And what I can now do is if I try to come here and say, yeah, now I want to change, now someone is trying to access that, and if they're trying to change it, like here I'm clearly trying to change it to nitrogen, and if I now print it, it still shows up as carbon. Someone tried changing it to nitrogen, but we still get it as carbon. So that's one way to encapsulate your data. This line is the same as non-existent. Why? Because we're not able to change what's being defined over here in the class so that your data cannot be tampered with. So that covers kind of like the basic, how do I say, encapsulation. And now the next thing that we need to do is called, I don't think anyone is guessing here. So let's go with polymorphism. Now, polymorphism is, as in other languages, it stands for method overloading. That means you can define the same method again and again and again in multiple variable times, and that variable will act differently depending on what arguments you give. And that was a lot of technical mumbo jumbo, but if I simply break it down, imagine that I can say a method called add, not add, we're not going into the generic ones. Okay. How about if I say def greenery? We want to check how much greenery is there on Earth. So I'll just define a method like this and say it has some fancy stuff inside. And then if I think, okay, maybe sometimes I want my greenery method to go without an argument, and then sometimes I want my greenery method to go with one argument that says species of some a species of a plant or something like that. And let's assume there's some magical stuff inside here. And let's say I want another kind of variable, another type of method, greenery, that should take species as well as, say, time of the year. Like every plant cannot grow at the same time, right? So something like that. So in other languages such as Java and I think C++ as well, this would be totally valid. You can define 3 different versions of the same method, and depending on what values you give to them, they will be taken care of. But that is not the case in Python. You cannot method overload in Python. Don't ask me why, go ask the creator. Just kidding. It's because of the way Python was created, and since Python is a loosely typed programming language should not cause a lot of issues later on in big projects and coding, that's the way it has been. So what do you do if you want to overload something? Well, what you do is, one way to do it is providing by how do I put it, default values. So let's say this method over here, let me just get rid of this, and this method over here, this show star, is a method that is defined in class planet. Now, what if I want to redefine that method to mean something else? That would basically be polymorphism. So if I redefine it over here in def show star, and yeah, let's just not put this on. We'll say print this is the method from the class earth. How about that? So now if we run this, and if we also call the method planet earth dot show star, what we will be seeing is this is the method from class earth. That is the line which gets printed over here at the bottom. But if if this method was not present in our earth class, if I just comment it out, and if I now run it again, what will be printed is the original line. This one, the planet of this, the parent star of this planet is sun. And that's basically as much as you can get with polymorphism in Python. What you can also do now is think of it this way. Now you want this method as well. You like this method, but what you also liked was the method of the parent class. It's kind of like you want the best of both worlds. So what you can do is just before and after, it completely depends upon you where you want it. You can say super dot show star, and what that'll do is once it has finished executing this statement, it will call the super dot show star method. I mean, everything that's in there will be called as well. So now we have this show star, which is completely overriding everything that was in the planet class, and if we run it, we'll get both of the statements. I mean, first this statement gets printed, of course, because that's what is before in the show star method, and then the parent star of this planet of the star is the planet. The hell is wrong with me? The parent star of this planet is sun. That's what gets printed. And with that, we suppose we cover the least basics of object-oriented programming. So that's it for this video. Be sure to leave a like, comment, and let me know what else I should be doing next. And until then,